Okay, so time for our next couple of mini lessons here. All right, so yesterday you did conversion from degrees to radians and back again, and then you did drawing angles from standard position. Okay, all of this is going to lead to something we talked about yesterday called a unit circle. Okay, and we need to do a couple more things before we start applying all of this to the unit circle and actually, working on equations and stuff that we do with it. Okay, now you may or may not have seen this in geometry when you did the trig stuff, the sine, cosine, and tangent. Okay, you probably solved for sides in right angles. You even probably solved for angles in right angles, which is good. But you may or may not have talked about what we call special right triangles. Okay, there are two very specific right triangles. They have specific angle measures. Okay, and the lengths of their sides make this really neat proportion that actually works no matter what size the triangles are. Okay, as long as the angle measures are the ones that are given. Okay, so we have them both right here. These are our special right triangles. Okay, as you can see, one is a 45, 45, 90 right triangle. Okay, and that means if both of these angles are 45, then the sides opposite them, right, corresponding sides, are also the same length. Okay, same, angle measures means the same length of the sides. Okay, and the proportion that it goes with is that whatever measure these two sides are, be it n, be it x, be it 2, whatever it is, right, the hypotenuse, the longest side, is that measure times the square root of 2. Okay, and you can prove this using the Pythagorean theorem, because we know that, side squared plus side squared, a squared plus b squared equals c squared, right? And no matter what measurement we put in for those two side measures, if we solve using the Pythagorean theorem and we don't get the decimal form, if we get the simplified like square root form of the answer, it's going to be whatever it is times the square root of 2. Okay, and I can prove it real quick. We can just pick a small number. Let's say we pick 2, right? If we pick 2, then we say, okay, 2 squared plus 2 squared is going to equal my c squared, right? C squared. Okay, well, 2 squared plus 2 squared is 8. Okay, 4 plus 4. And if I were to take the square root of 8 and not get the decimal form, get the simplified square root form, this is whether or not you remember how to do, simplified roots, which is kind of important for those of you who are still planning on taking the ASVAB or are still planning on taking the SAT. They have those portions of the test, right, with no calculator, and you have to be able to do this by hand. So when we simplify the square root of 8, okay, it breaks down to the square root of 4 times the square root of 2. Okay. And what's going to end up happening is, well, the square root of 4 is 2, and this square root of 2 doesn't break down, so it's 2 root 2. Okay, so that works. 2 and 2 are my side lengths, and the hypotenuse is 2 times the square root of 2. And again, this works no matter what measures those two sides are. They could be 3, they could be 5, they could be 100, right? Because if we do 3, then it's going to be 3 squared and 3 squared, that's 18. Square root of 18 breaks down to 9 and 2, so that's, 3 square root of 2. So it follows this proportion, okay? So it's very, very important that it does follow this proportion, and we're going to be working with this today, okay? The other special right triangle has a 30, 60, 90 proportion as far as its angle measures, and it follows this proportion when it comes to the sides. The smallest side, because it's across from the smallest angle, is our, our base term that we call just n. Our hypotenuse is twice that size, and the long leg is that size times the square root of 3. And again, we'd have to fill in a couple of sides to get this one to work. We'd have to fill out, what n and 2n are to prove that this would work. And I can do that real quick. Let's say that we say that n is 3. So then we have 3 squared plus, we'll say b squared because that's the other leg. Okay, and if that's 3, then this has to be 6, right? Equals 6 squared. And we were doing something very similar to this with the conics when we were solving for like hyperbolas and stuff, although we went ahead and just actually got the decimals for it. Here we're not going to. So 9 plus something gives me 36. Okay, well that something has to be 27, right? So 36 minus 9 is 27. If I break down the square root of 27, which is, what we're doing, we're simplifying it. Your little yellow calculators are really good for this, but again, you really should learn how to do this without a calculator. 27 breaks down to 9 and 3. Well, what is the square root of 9? Correct, it's 3. So this is 3 root 3. So whatever measure this one is that measure times the square root of 3 every single time. Okay? So we need to make sure that we keep this drawing somewhere in your notes where you can study it. And we're going to actually talk about how we work with those proportions. We're going to actually do several examples today, working forwards and working backwards. Okay? And this will actually help us with all the stuff that we've done work on the unit circle as well. Okay, so basically could be x, could be n, whatever it is, x root 2, x, 2x, and x root 3, however you write it. But we're going to do several examples today, and this is what you're going to work on first. And again, these work no matter how big or small the triangles are. Okay, so we'll start with an easy one. We have a 45, 45, 90, and one of your leg measures is 6. Okay, well, if one leg measure is 6, that means the other one is also 6, and that means the hypotenuse is 6 root 2. And I don't actually have to try and go and solve for that using the Pythagorean theorem, because I know from my notes back here that that is the proportion, that is the way the proportion works. Okay? So now, if I have a 45, 45, 90, and the hypotenuse is 5 times root 2, again, based on that same exact proportion, I know that my side lengths are 5 and 5. Okay? So pretty basic if you're given one of the legs or the hypotenuse on this. Now let's see if we've given something that's a little bit harder. Okay? So, again, I've been given the hypotenuse, but notice there's no square root on here. Well, that's not a big deal. We're just going to do a little simplifying. To go from my leg to my hypotenuse, I multiply times the square root of 2, right? So to go from my hypotenuse to my leg, I would divide by the square root of 2. And this is going to require a little bit of work on your part. You're doing 7 divided by the square root of 2. Okay, and we can't leave a square root in the bottom of a fraction that way. We have rules about that, just like I told you before about not leaving decimals inside of a fraction that way. Okay, so and again, for those of you taking the ASVAB or the SAT, very important that you need to know how to simplify this by hand. So how do we simplify it? Well, we multiply the top and the bottom, because whatever you do to one, we have to do to the other. We multiply it by whatever the root is on the bottom of the fraction, because we want that to be a whole number. We don't care if there's a root on the top. So if I multiply both the top and the bottom by the square root of 2, then I get 7 root 2 on top, and that's okay. That's fine. Well, the square root of 2 times the square root of 2 is the square root of 4. And what is the square root of 4? It's 2. And that works because if you take a square root and you square it, you multiply it by itself, you just get the whole number that's inside. And that's how that answer needs to be written, as 7 times the square root of 2 all over 2. All right, try it for this one. I'll give you a minute or so. You're going to set it up the exact same way. And you see if you can come up with what the 2 leg measures would be. And yes, if you, in case you're wondering, you do have to actually write it as an improper fraction. Some of you noticed that yesterday on the radians and the degrees, you do have to write those radian measures as an improper fraction, not a decimal, please. So that is 7 over 2, 7 times root 2 over 2, not 3.5 times the square root of 2. So try this one. I'll start it for you. You know you have to divide 1 by the square root of 2. Okay, so simplified. Simplified by multiplying by root 2 over root 2 should give you 1 root 2, or you can just write it as the square root of 2, all over 2. And we normally would read that as the square root of 2 divided by 2, or root 2 over 2. Okay, it's just a shorter way of saying the same thing. Okay, so that's how you simplify given the 45, 45, 90s. Doesn't matter what you're given, the ratio is always the same. Okay, so you're either going to be multiplying or dividing by the square root of 2. Okay, so the 30, 60, 90 one is a little bit trickier because of that root 3 measurement. All right, so let's try an easy one first. If I tell you that the small leg, remember that's the one that's across from the small angle, is 8, go back to the ratios. That's my base measurement that I work with. Okay, I have to multiply that by 2 to get the hypotenuse and by the square root of 3 to get the long leg. So if I tell you the short leg is 8, that means my hypotenuse is 16 and my long leg is 8 times the square root of 3. Okay, so it's always better to get back to that base measure first. All right, so let's check. If I give you the hypotenuse and I say it's 14, well, what do I have to do to get back to my base measurement? Good, I have to divide by 2, so that makes this 7, and that makes the leg 7 times the square root of 3. Okay, and again, it always follows the same proportion. Whatever the small leg is, the hypotenuse is twice that much, and the long leg is times the square root of 3. All right, so let's try a little bit harder one. Okay, so I've given you the long measure, 4 times the square root of 3. So if I multiply by the square root of 3 to get the long measure, then I have to divide by the square root of 3 to get the short measure. So that would be 4. And that means your hypotenuse would be 8. Okay. This one is very, very important. Dealing with a hypotenuse of 1 is something that's going to help us on that unit circle, because remember that radius of 1 thing? That's going to come in there somewhere. So if the hypotenuse is 1, and again we're going to write it as a fraction, not a decimal, the short leg is 1/2, okay? And the long leg is 1/2 times the square root of 3. So we write that as the square root of 3 over 2. Okay, and we're going to do one more, a little bit more complicated, just to make sure you've got it. It's a little bit more complicated because you actually have to divide by the root this time. All right. So there's my 30. There's my 60. There's my 90. And I'm going to tell you that this time the long length is 8. Okay, so again, if I go from the short to the long by multiplying by root 3, then I'm going to go from the long leg to the short leg by dividing by the square root of 3. This is very similar to what we did on the last triangles. We're going to do 8 divided by the square root of 3, and we just need to simplify it. Okay, simplify it. Well, we multiplied by the square root of 2 last time because that was what was on the bottom. This time we're going to multiply by the square root of 3. Okay, and we're going to simplify this down as far as it can go. That's going to be 8 times the square root of 3. And on the bottom, well, square root of 3 times the square root of 3 is the square root of 9, or 3. And that's our answer as far as what the measurement of the short side would be. So that would be 8 root 3 times 3. We're not quite done yet. If we want to actually get the hypotenuse, remember that the hypotenuse, you take the short measure and you multiply it by 2. So if I take 8 times the square root of 3 divided by 3, and I multiply that by 2, the only thing that gets affected is the top number, okay? And that's just going to be the whole number. That's going to be 16 times the square root of 3 over 3. So that's it. That's how we actually get the measurements for it. Now, what I want you to do first, I want you to go into Canvas. There are 2 pages on this worksheet, and there are 8 problems for the 45, 45, 90, and there are 8 problems for the 30, 60, 90. Okay? I'm going to go ahead and stop the video now, and I'm going to give you the choice on whether or not you're going to watch the second video, because the second video is how we put all of this together in the unit circle. Minimum, you have to get all 16 problems done by the end of the school day. You should be able to get those finished before you leave school today. Several of you still don't have full grades for yesterday's, and as I stated in the remind, I'll put a grade in as collected if you turn it in and you have corrections that need to be made. But if you don't turn it in at all and you weren't absent, you're getting a 0. You need to step up. This is the beginning of the 9 weeks. You need to make sure your work's getting done. Okay? If you don't watch the second video today, you can watch it on Wednesday. It just depends on how long it takes you to get those that assignment finished. But I will have both of them posted. All right, take it easy.